Hello folks, well it's a bit earlier than I usually do these. We're at 8 in the morning, don't normally start work till 9, and thing is, I bought a car. As you probably know, we've got an ancient Toyota Corolla. When we took it for MOT last year, it says don't bring it back, and it's got some corrosion issues. Now it's 27 years old, is it? Anyway, it will be heading to being scrapped. But the problem is that we needed another vehicle. As you know, we have an electric Nissan Leaf, which I bought to do the tests and to do the church work and things like that. I didn't do it to do DX kind of journeys. That's why we have the Toyota. So I've bought another elderly car, being on a tight budget, and we're going to pick that up from Huddersfield, which is about 85 miles from here. So of course when you pick a car up, it doesn't have a CB radio in it, and of course when you buy a car that's 19 years old, you may have some shenanigans with it, and so I really need communication. I'll be having to drive it because I'm going to have to arrange one day insurance. So I need a Midland Ready Rescue or similar, and the first one to come out of the thing is a Midland Ready Rescue. So how complete this is. This one's faded, hasn't it? This is actually complete, isn't it? Good. We may be in with a fighting chance with this one. I'm going to use... We do these for the Midland 77805. And we've got them on eBay, so it's the correct connector to an open end with an inline fuse, and it's going to fit these as well. The trouble with the cable it comes with is when you're tuning up the transmitter, it can restrict the power. This is a 3 amp rated cable, whereas I think the one you get with it is 1. So I'm going to do it that way just so we can do the tune up. It's not that it draws more than 1 amp in transmit, but during the tune-up it will try, so we need to let it do that. So that's what that's all about. So we'll borrow one of our cables from stock, and there we go. These are 12 volt radios, so we're going to have to run it at 13.8. At least it's mine, isn't it? And let's see what happens. And the answer is probably absolutely nothing, because I've turned it on and it's doing absolutely nothing. So why would that be? Well, we'll go back to the drawing board and we'll get the provided cable. I'm going to use heftier mag mounts than that with a normal aerial, because they are quite restrictive in range. Those, you know, you certainly aren't going to get more than like 3 or 4 miles. So I'm just going to try it with, just in case we've got an issue with the fit of the cable which we provide. It may be the wrong one. We didn't. I've never tried it with one of these. That looks like it's a thinner centre. And then we're back to the problem that actually it's a thicker cable than I've seen. Yeah, that's absolutely fine. So our 77805 cable isn't suitable, so that's fine. Right, so we're going to run it on that. Where's the clipboard? And I've got 2 of these to do. We've taken the radios out of the Toyota car ready for it to be scrapped. We have to use that to go up and pick this up, of course. That's why we're doing this before the MOT expires. It drives all right, it's just underbody corrosion that's beyond what we're prepared to spend. Right, so it is, I say just, yeah, April 82. It's 001924, April 82. and it is the 25th of June 24, Midland 77 810 UK. So the only shenanigans you can have with these is this knob has to be on right. At the moment it reckons to be on channel 36. Let's put it on what we think is going to be channel 20. That's where an LED display would help, and the realistic would be a better one. But there you go, that's what we've got on the shelf. I need an aerial adapter because it uses an RCA connector, which really also doesn't help with your aerial connection. So we have a Motorola to SO239 adapter. So that fits in the back of an old-fashioned car radio, or it fits the RCA phono. It fits both. So we'll now connect that to the... If they'd put a BNC on it, even if it cost another 50 pence, but no, they didn't, did they? On any of these type of things. Right, so let's put picture in picture on, and first of all make sure that the right camera is on. That's it. Okay, picture in picture on the monitor. I'm on channel 20. Let's press transmit. Well, for some reason we now have no power. Oh, because I turned it off. That's actually got plugged into the roof area instead of the test instrument. Let's try again. Doing 2.6 watts. I'd like it to do more than 3.5. Just going to change channel. Oh, was that channel 20? No, it wasn't. It's channel 21, so the knob's in the wrong place. It's 27 79092. The test gear's been on a reasonable amount of time, so that does want pulling up, but it's not stupidly off. Let's go and find channel 1. So, where's that? That's channel 1. And it's doing 2.6 watts. And channel 40 is doing 2.6 watts. Do these have low power? The Maxcom one does. No, these don't. And let's go back to channel 20. And it's 794 milliamps. Deviation for what it's worth on this test set. Wallow, it's 2.1. I'll put it there because we're going to test that in the other test instrument. We won't need to do the VCO. And let's see what... Well, it hasn't got a... I can tick these boxes off. Good. Well, that's that done. I might do the other one straight after this on this same video. If I can get through these quick enough, if I can do this in that 25 minutes, we can do two at the same time, and then we can look at how they compare. So receive. I'll just stick 2779125 in the signal generator, and then we'll put the actual frequency in. And the actual frequency is 27.79092. nearly. Right, let's go back onto the cyanide meter. Ah, we can't do cyanide because it doesn't have an external speaker socket until we've taken it apart. So pull the knobs off. Some of these aren't discoloured like this, but this one is. Look, it's been in the back parcel shelf of a car for 10 years. So this and the Maxcom 70 are identical electrically, but as I say, I think the Maxcom 70 has got the low power. Because it had that battery pack option, if you remember, it came with a carry case and a battery pack. To be careful we don't rip the speaker off. Which way is it going? Tell you what, we'll have it that way. Oh yeah. Right. Whoever MB was did it in 1984. I have seen somebody put a 3/8 stud mount, or put an aerial into the 3/8 stud mount. You can't do that. You can only use the aerial it came with because it has this loading coil. Right, so we need a crocodile clip. Where am I going to find that? Which bit of the floor? Yeah, I'm right. There's a white one on the floor that'll do nicely. Now it's quite possible we only have to connect to the inner because it'll pick its earth up through the aerial's earth. Let's just see. Yeah, absolutely right. There we go. So with the cyanide meter now connected, we'll drop the signal generator and drop the scroll. Like anything else with RCA connectors, it will actually work better than the way we're able to read it, because that's lossy. So we've got, it's absolutely fine, it's 0.71. I've just knocked it off frequency because my hands are too big. It may only be 8 in the morning, but we've got the air conditioning on in here. Right, 10 dB is 0.65, 20 dB if it will do it, is 1.8. Squelch. Is 2.3 millivolts. It's too tight. And at the bottom end, .7. That's fine. So that's it. Straight onto the tune-up. So we've got, out of the instruction book, we've got a layout, which is the top, which is the bottom. So you've got 2 presets, One is deviation, one is squelch. I can't remember what the tune-up is on these. And this is such a bad circuit by the time it's been blown up off a photocopy. Oh dear. I can't read that. So it's going to start there. That's going to be deviation because it's nearest the phase lock loop, and that's going to be squelch because it's nearest the receiver. So it's going to be, transmit is going to be up here and round, receive is going to be there, and the detector is going to be, yeah, I don't know whether it's going to be that one or that one. We'll find out. Back to that circuit diagram. I don't expect I can see just the detector. I can't. It looked like something like T8. Is that possible? If it's T8, it's that one. Anyway, we'll start with transmit. So we have to press the transmit button. Well, first of all, we'll go into the test set. We're on a 3-watt scale, and we want peak. That was already correct. I think we've gained a fraction there. We've gained a fraction there. Of course, it's heating up, the transmitter's dropping down. Right. Soldering iron on that one. It's 2.8 watts. That's gone beyond our scale, so we'll switch to the 30-watt scale. I'm just going to put it on 13.8 volts. It isn't a 13.8 volt radio, but it is my radio. I'll just see where we are on 13.8 volts. It's a whisker away from 4 watts. The fact remains is we're going to have to run this on 13.8 volts. I'm really not going to start putting some kind of dropper arrangement in. So it is exactly 4 watts on 13.8 volts. But we're testing it at 12. So we'll go back to 12 volts. And we have 3.4 watts. And here's the fun, changing channel. No idea where I am, you see. 9, 4, 5, 6, 7, 8, 9. That's channel 40, and it's doing 3 watts. Channel 1 doing 3.1 watts. So we've definitely got the peak where it should be, and it is doing 4 watts at 13.8 volts. So back to channel 20 if we can find it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is probably about there. No, it was right, I was. So the right number of clicks I counted. There we go, 27.79125. Current consumption is now 840 milliamps. Right, we need to do deviation, so we'll put this on the test set behind me. We're going to have the tool ready in the preset there. Now this is the novel bit. How do we disconnect that. I've got to kind of pick this all up. Because the microphone is there. Voila. Voila. Yeah, it's reading right today. Right, so that's transmit done. It was 2.1. It's now 2.2 to 2.5, as it should be. Let's go to the receiver. Look at our white clip back on the speaker. Start with the detector. Put S9 equivalent signal on. Turn the volume up for a meaningful trace on the oscilloscope. And I think it's that one, but it could be that. Miles out. Right, over to the cyanide meter. That was spot on already. Little tiny adjustment there. That was miles out. Let's get a new cyanide reading. Let's put the power back on. Let's get a cyanide reading. And because I've adjusted the detector, it may be worse. It's not, it's slightly better, 0.64. dB, 0.59. And for 20, .35. Now we need to do the squelch, so that's going to be the other preset. Put the glasses on so I can even see it. Oh, it's vertical. No wonder I couldn't see it. Don't we love vertical presets? No, it's not. It's there under the wiring. So I'm going to set the signal generator. I'll show you the attenuator. We'll set the signal generator for 100 microvolts. No, we won't. We'll set it for 30 and then turn the squelch to full. And then we're going to turn the preset till it opens. It doesn't. Right, we'll go to 100 microvolts. Now we'll adjust this back to 100. Does it open? Not quite. Very carefully adjust this. Adjust weight. Adjust weight. Adjust weight. That was it. 2, 3, 4, 5. Just need a fraction. That's it. 100 microvolts. That's where I want it. So it's squelching out as high as S9. That was plus 30 and beyond. So now we need to check the sensitivity again. It was 0.7 before for squelch. It's now 0.62. Lovely. We're done. That's it. Looks like somebody scored a key across there. So I must remember we need to order some connectors so we can make power leads up for these. And although I'm not a lover of cigarette lighter plugs, I can see why you need a cigarette lighter plug on these type of products. So it's probably now about 8:30 in the morning. Let's see if there's any good buddies or bad buddies out there. We need to align that so that it's lining up with channel 20, which is there. Put those to minimum. I think it's had a lot of use, this, but it's working great. Right, we'll now plug the roof aerial in instead of the test equipment. Normally at this stage I'd switch the test gear off, but we'll see if we can fix another one. So we've got a double Midland 77 810 because they're all different. If the other just needs a tune-up, it'll be quicker because we're set up for it, aren't we?
The looking at the watch then, yeah, we'll give 10 minutes to shoot score, and 15 days.
So we don't have to go far, one down, and Roger, for there to be some swearing. There we go, that works fine. So, right, that's it. I'm going to put this power lead back in the box. We're not going to use the aerial, we're going to use a bigger, more substantial mag mount, so I don't need to test that. Could do a neater job of all these wires. Right, that is ready to take with us. Let's see if I can find another one. Okay, so here's another one, but we've got another 3, but none of them have got power leads. So that's going to be a bit of a problem, isn't it? Now, this is one which somebody's made this stupid battery pack on, turned it into a walkie-talkie. That's going to take some time. Whilst I was looking, I found this, which is an American one, so I didn't realise we got this. I'll have to scrap this for legal reasons, but it does come with, that's not the original, that is not the original adapter. No, it's too wide, that is not. What it does come with, it comes with a mag mount, but it comes with a rubber duck aerial, which is not what we had in the UK. We can see it's an American one because it doesn't have the 2781 logo, and it has the FCC data panel on the back. So that's going to have to be a scrapper, but at least it's got some knobs. So, and the aerial magnetic base is there. Right, so we've got to remove this battery pack. Can't get that off. Right, knobs off. Now I need to get this out of its case, which is easier said than done because we've got to unsolder the aerial. Or do we? Yeah, we do. I thought the second one would be quicker. Don't think there's any screws. It's got to be the most tight-fisted walkie-talkie. They could have bought the Maxcom 7Es, which had the battery pack, except they were £20 more, or £10 more or something. Right, so it is just glued on with araldite or something. Yep, I'll get on with the tune-up and then we'll go across to the workshop and deal with that. So, right, so I'll just get myself another sheet of paper. Don't know which, well, what the serial number is of this one until I manage to get that unglued. Right, here it goes. Test set into main meter. Nothing coming out. Well, certainly some wicked dry joints. A little bit of ingress of moisture here. I'll give that a go. Power back on. Still nothing coming out. Right, let's see whether that's strengthened the spring up enough. If that's the issue. There we go. We have transmit. So dry joints and dodgy socket. Let's see what we've got. 2 watts. Channel 1 is 1.8 watts. Channel 40 is 2 watts. Back to 20. And 1, 2, 3, about there. Yeah, 643 milliamps. Let's do that right away. I'll set the frequency on this straight away because we've already got everything's warmed up. So we'll just see what that is. $27,79116. It's virtually spot on. Right, let's just get straight on with the transmitter. It's a bit low, isn't it? Let's go back to the main meter so you can see what we're doing. We're at 2.3 there. I'm going to ramp it up to 13.8 just for the tune-up. .9. That's over 3. 3.1. Not as good as the other, is it? I'll just check it hasn't had any of these messed with. Yeah, that's not in the right position. Check these again. Probably about 3.4 now. Right, back to 12 volts. It's now pretty hot, so it's not going to be true. .9 watts. Nine, 5, 6, 7, 8, 9. Channel 40 is 2.8 watts. Channel 1, 2.9 watts. Back to 20. That's where we are. Current consumption is 707 milliamps. So what, we'll do deviation straight away. I'll use this test set because it seems to be working right today. Wallow. Wallow. That is dirty. Wallow. Double check it with the other test set behind me. Wallow. No, it's far too high. Wallow. See what it says now. Wallow. Yeah, it does read right, but anyway. It's 2.1, 2.2 to 2.5. Not applicable, not applicable. TX LED dry joint. Let's deal with that. I wonder if this has been on somebody's boat and it's sat in a locker getting damp. There's no visible dry joint, we'll just reflow this. That's it. Right, so we'll now do the receive. The same as before. Put that on the speaker. And we'll go over to the synad meter, and for 12 dB we've got 0.9, which is actually about where it's supposed to be. This doesn't work as well as the other. 0.82. dB, 1.8. Full squelch. It's 3 millivolts, so it's too high again. Threshold. Is not good enough at 1.3. Right, so let's go through this. So with an S9 signal on the test set, let's go over to the oscilloscope. And do the detector. Right, to go to the synad meter. See whether we can get a bit more sensitivity out of it, and of course remove the power as usual. The other thing about this low power, I don't think this power lead can handle. Right, here we go. No improvement there. No improvement there. Big improvement there. Got a new reading. So for 12 dB it's 0.79. .74, and for 20 1.6. So let's look at the other set. Yeah, other set receives better and transmits better. Squelch. Right, preset is there. Squelch to full. 100 microvolts on the test set. That's dirty as well. Yeah, it's been damp, this. 100 microvolts. Let's look at the sensitivity. Zero point 0.6. 0.62, so similar. Right, so there we go. I'll go across to the organ workshop and we'll try and separate this without breaking it. Right, so pile of elderly nickel cadmium batteries is a 500 milliamp hour. They can go on the floor. We better take those to the recycling thing at the council. So I will one day peel this off. It's one of those things you could spend a happy evening doing, isn't it? But I need to use this set today, so I'll use it like that. But we've accessed the serial number. It's April 82 00001012. So let's just look at the other one. The other one slightly later, but another April one. So put that back in its case. To slide that holder down. I've got to kind of get it under there at the same time. Solder that back, just in case it's ever used with its original telescopic aerial. Just do a final check of what power it's actually doing. Now it's cooled down. It's exactly 3 watts on 12 volts. We'll go to 13.8. Change scales. It's 3.5. Right. Somebody went to all that trouble to make a cheapskate walkie-talkie. It's probably only this in the realistic. They didn't have a battery pack option. So where's the other screw gone? You couldn't make it up, could you? Well, this American one can give me a screw. We'll do a double on the air test later on when we come back. We'll go out with the first one we did. We'll go out again. I've got to do it the same direction because it differs. We'll go out with this one but do a kind of edited highlights You don't want to see the same route twice. So, just stick the knobs back on. So channel 20. We'll swap that for the aerial. Same bloke still swearing. Let's put it on 19. Well, no, Roger. No. Let's see if we can hear what these sound like. Be quicker to change channel on this. Let's go to 20. Testing 1 2 1 2 1 2. Yep, fine. Good. Right. Well, thanks for watching the double 77-810. That was a surprise on the second one. I'll see you later on on the air test.